Yeah. So good afternoon, everyone. It's okay for some? Okay. So yes, that's the last session of the day and of BriForum, and you will have to deal with an awful French accent. I apologize for that. I know it's more difficult for you, but it's also difficult for me. Welcome to this session about one accelerator for desktop virtualization, and I want to thank some people. So Eric Julien is really the expert in France around branch repeater and Escalar technology, and I work also with Zico and Exclusive Networks, the French distributors of Riverbed and Blue Coat and Silverpeak. So first, precision about the content of this session, because when I wrote the call for paper, it was branch repeater and other one accelerator for desktop virtualization. However, if you listen to Bry and Gabe's session announcement on March, he said, Vincent, if you are listening, take notes. So, to be honest, I wasn't listening, but Jonathan, my engineer, told me. But so I took notes. We don't want you to focus on branch repeater only, okay? We want you to focus on one acceleration products in general, okay? That's why now the title of this presentation is One Accelerators for Desktop Virtualization. So we won't go in depth of each product, but we will really compare all these products. So I will explain why I have chosen 4 products only. And we will see how, I will present also 2 use cases I had this year, so past year. One with branch repeater and one with Riverbed, and why we chosen this one. Just to say, Infralis, so my company, we are 2 consultants, and we are helping our customer to choose the best technology for their needs. So, after the Geek Out show, I had the idea this morning to add this one. Okay? You remember why? So now you know you can revise your network knowledge for the next Geek Out show, perhaps in Chicago or next year in London. So I think you know that. So here is a typical architecture with desktop virtualization benefits. I mean, we have here a headquarter with a big link here, and several branch offices over the country or over Europe or over the world, and with some mobile users. And desktop virtualization is commonly used to access to application in a very good way and a very manageable way. So one is really a potential issue with desktop virtualization, also as storage, for example, when we talk about VDI or hosted virtual desktop. So the typical analysis I can see from some integrators, so in France, I don't know if it's the same in other countries, but they say, so, okay, we have to deal with bandwidth, no problem, just you have to do some math. One user equal to 20 kilobits per second. And you have 10 users, so okay, you need 200 kilobits per second. And they don't say if it is an average, if it is a maximum. And what about printing? I read sometimes in some requests for proposal or sometimes in proposals, something like one printer is 40 kilobits per second. What does it mean? Nothing, really nothing. And so, of course, it's an average, because if you are doing some Flash application or intensive web browsing, it's not 20 kilobits per second. And nowadays, because we have VDI, we want to deliver a full desktop with a lot of application. we cannot manage all applications. And we don't know on which website users will go. I'm sure you have in every country large website with a lot of Flash applications, Silverlight, and so on, and it can go to up to 300 kilobits per second, for example, for just one session. So I see sometimes this number. Before it was 20, now it's 100, but also I think it's only an average, and you don't have to deal with that. So there are a lot of things we cannot manage at the farm level. For example, all TCP flow control between routers. Of course, we cannot manage that from the farm. And congestion on the network also. Data duplication between several servers in the farm. And of course, quality of service and traffic shaping between your routers on the WAN. So all of that is not manageable from the farm, so you have perhaps to manage that in another way. I'm sure you know already this thing, but I will explain very quickly. You know what the TCP windows is. You know the TCP is a transport layer. So the default size of the flow control mechanism with TCP is only 64 kilobytes. What does it mean? If we take a network with a bandwidth of 1 gigabit per second and a latency of 20 milliseconds, what happens exactly if we don't do anything special? T equal to 0, we are sending the first data. Okay? After a half millisecond, the window is full. So we stop to send data. Okay? We need then 20 milliseconds so that the data arrive here in London. Okay, we send then the acknowledge, and we need 20 milliseconds more to receive the acknowledge and then send new data. Okay? So if we do some math, the efficiency of this network, if we keep the flow control window to 64 kilobytes per second, is only 1%. That means you use a throughput of about 13 megabits per second. I remember you have a 1 gigabit per second link. Okay? So we have to deal with this TCP window in order to put more data on the link to really manage this link. Congestion. So congestion is something very famous here in London. There is a overall congestion charging here. And the problem is how to keep a fast sender from swamping a slow receiver with data. And today, the solution is to use a feedback from the receiver. And then we can manage what we call a flow control. However, if the network is oversubscribed because too many computers want to send too much traffic, then the network cannot deliver it, and we have congestion. And when we have congestion, a lot of packets can be lost, and then must be retransmitted. And so we are in a very bad situation in this case. A typical false solution, I see that with many of my customers. They have congestion. They don't know exactly why. They don't know the problem, the issue, but it doesn't work. And they say, okay, we have 1 megabit per second. It's not enough. We need to double the link. Then they buy a 2 megabit per second link. And it doesn't work. Okay, they buy a 4 megabit per second link. It still doesn't work. Because here it's very good written, that's why I copy and paste this sentence, but by additioning capacity, you just reduce the frequency and the duration of the congested states. But it doesn't solve anything really, okay? And of course, it's a real problem for real-time application. Here in the sentence, it talks about voice over internet protocol, for example. But of course, our remote desktop protocols are typically real-time protocol because any problems, any issue, any congested state involve immediately a bad user experience. Here are some examples. I'm sure you already watched this kind of graph with your telco because you want to know why you have congestion or not, or if you have congestion or not. And here, if you look here with a 1 second sample, you can see, oh, I never have 100% of utilization. So I have no congestion, no problem. But it's strange because it doesn't work very well. If you reduce the sample here, you can see no congestion. If you reduce a little bit more, you can see, oh, eventually I have some congestion on my network. And if you look more precisely at the packet level, you can see that your network is frequently congested. And that's why you have really some issues with your user experience. So that was the bandwidth issue, I would say. Latency. Latency is, of course, also a known issue with WAN. User experience is very sensitive to latency. Remember, I don't know if anyone here already used local text echo a few years ago. It was because of latency issue. And so the latency is an expression of how much time it takes for a packet of data to get from one designated point to another. And we measure by sending a packet that is returned to the sender, and what we call the RTT, the round trip time, is considered the latency. So really one from A to B and B to A. Another point is what we call the jitter. The jitter is a variation in the delay. If, for example, you have a latency of 200 milliseconds, so it's big, but if you have all the time this 200 milliseconds, or perhaps sometimes 210 or 190, you can deal with it. If you have an average of 200 milliseconds, but some peak to, I don't know, 300 or 400 milliseconds, and sometimes you can have some packet with just 100 milliseconds, it's exactly the same average. But the jitter is very high. And the jitter is also very important for all real-time protocol as remote desktop protocol. A third issue with WAN is the loss of packets. We can lose packets for two main reasons in a WAN network. The first one is if we have network congestion. If we have network congestion, TCP, so the TCP IP stack, will try to really destroy some packets just in order to continue to send new data. So that's the first point. The packets are dropped by routers because of congestion. Another possibility is the transmission bit error because the link has a low quality. It's also possible. What happens? What are the solutions with the TCP/IP stack? The route transmissions of packet by the transport layers. That's the role of TCP, for example. Okay, and you know that UDP doesn't have such a mechanism. And sometimes it's better to refuse the packets because we don't want to wait for a video, for example. If you don't see some pixel, it's perhaps not so a graph for the user. And if packets are lost, retransmission involves bandwidth limitation. And we can really calculate that with a formula. So a mathematician did that work for us, okay? And it demonstrates that the throughput is limited by the maximum segment size and the round trip time and the percent of loss. If we make a simple example here with a common segment size and RTT and percent of loss, we have the throughput is limited to 1.2 megabit per second. If your link is 1 megabit per second, no problem. If your link is 2 megabit per second, you won't use it anyway. And if you decide, for example, to double your link because you think by doubling your link it will be better, here it's completely unnecessary. Okay? Because this formula is very interesting because the throughput is limited by some elements but not the bandwidth, not the real bandwidth. Okay? So that's always very interesting to have that in head because it's very important, and the impact of loss on bandwidth is really a major issue in a network. So, first conclusion. We consider today that for real-time protocol like remote desktop protocol, we can have some value in order to know if we have an issue on our WAN link or not. And for example, we consider that we have network congestion if the network usage is constantly about 25–30% because of the graphs I have shown to you. Okay. If latency is above 75 milliseconds, user experience is affected. If jitter is above 50 milliseconds, user experience is affected. And if packet loss is above only 0.25%, then also user experience is affected because of what I just said before. Okay? So, to deal with that, we can use QoS, quality of service, and we have to address 4 issues. The first one is what applications are needed for the network, on the network. The real time, of course, have to be prioritized. How to regulate the traffic that enters the network in order to avoid congestion. That's the same to how to reserve resources at routers to guarantee performance. And of course, whether the network can safely accept more traffic, because we want a big TCP window in order to put maximum of packets on the network. So, in order to choose the 4 WAN accelerator I wanted to compare, I work with the Gartner Magic Quadrant. And I had a look on the evolution since 2009. So that's here in 2009. You can see, for example, Expand Networks doesn't exist anymore. And in 2010, here's the progression. You can see a big progression of Silverpeak system. And the last one is from January 2012. And you can see also progression of Silverpeak and the decrease of Cisco systems. That's why for this presentation I decided to compare Riverbed, Silverpeak, Bluecoat, and Citrix. Citrix because it's almost one of the leaders, and of course it's very interesting to analyze it with remote desktop protocols. Okay, I will talk a little bit about Cisco at the end in the conclusion. Okay. So now the idea of this presentation is to compare Riverbed, Silverpeak, Bluecoat, and Citrix only for remote desktop protocols. So we don't want to do any comparison with CIFS, HTTP, or something like that. Only 3 protocols, ICA, RDP, and PC over IP. I don't do anything with RemoteFX because it's considered right now as a non-WAN protocol, even if we know that in the next release of Windows 8 or Windows 2012, it will be possible. So I'm sure that these vendors will propose some optimization. So Riverbed and Silverpeak are 2 companies really focused only on WAN acceleration. Okay, they developed a product really specialized in this environment. So they both have physical and virtual appliances, and one have a client-side agent, so still and mobile. That is, you can install an agent on a laptop, for example, and have some benefits, some optimization if you connect, for example, in Wi-Fi or in 3G, okay, to your network. Important for Silverpeak, they don't have any client-side agent software, and they don't want. I asked them, and they say, no, 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 no. We are specialized with data centers, branch offices, and so on. We don't want to develop any software component for our laptop. So it's important to know that for remote desktop protocols. So Bluecoat is the oldest one. So I mean regarding WAN optimization. They were specialized in web caching, and they acquired Packeteer in 2008. So they still have 2 products as physical appliance, and sometimes it's difficult to know exactly what products we have to choose for remote desktop, because Mac5 is really like a WAN optimization, and Packeteer more like a TCP optimization. So it's sometimes difficult because some TCP optimization are also present in Mac5. And as virtual appliance, it's only Mac5. They have a client-side software. And of course, Citrix. And Citrix acquired Orbital Data in 2006. It was one scalar. And now it's called Branch Repeater for the branch offices and Repeater for the headquarters, for the main data center. They have a VPX, so the virtual solution. And of course, they have a plugin for the Citrix named Citrix Repeater, okay, for laptop. So pretty interesting. Important to know, before optimizing any flow, any network, you have to do some job. The first one is it's very difficult, of course, for one accelerator to make improvement with an encrypted flow, okay, because he doesn't know what's happened in the flow, so he cannot do a lot of things. So here, the idea is to non-encrypt the flow. Exactly the same applies for compression, because it's always difficult for compression algorithm to compress already a compressed flow. Okay, the result is not so good. So all these appliances try to manage that either automatically or in the documentation that tell you you have to deactivate compression, you have to deactivate encryption. So here, of course, for ICA, Citrix is the best one because you already know all the encryption key and so on, so it doesn't need to do anything, okay? So your flow is still encrypted, but not compressed. And for RDP, it's manual for all the solution. That means that it's at the server level. And for PC over IP, it's simply impossible to have an unencrypted flow. Okay, it's not possible. So you can do very few optimization in this case. Here it's interesting for ICA, for Riverbed, Silverpeak, and Bluecoat. Silverpeak and Bluecoat, you have to do it manually, then at the server level. Riverbed, since iOS 7.02, so just last March, 2 months ago, they can do it automatically for standards of basic encryption and advanced encryption for the ICA flow. Okay? So of course there is some struggle between Citrix and Riverbed because Citrix said to Riverbed that it's not supported by Citrix. Okay? But they did it and it works well, to be honest. Of course, the flow can be re-encrypted between both appliances. Okay? So you can deal with security if you want to. So now we will see what kind of optimization we can do with this one accelerators. We will split that in 3 parts. The TCP optimization. Oh, sorry.
Sorry, you moved on. So my traffic is only going to be encrypted on the WAN and on my internal network between my servers and my...
It's not encrypted. With Riverbed, it's not encrypted.
So I have to put them as close as possible.
Exactly. Exactly. Yeah, it's really an issue. I know a lot of companies that decided to not use Riverbed, for example, because of that only. It is not true with Branch Repeater. So it's encrypted. It's still encrypted. So the second part is compression and deduplication of data. And the third one is quality of service. And only, I will analyze only ICA, RDP, and PC over IP. So TCP optimization. There are a lot of TCP optimization. And well-known TCP optimization, I mean, since the beginning of TCP IP, okay, in 74. For example, for TCP designers, the maximum value corresponding to the infinity was based on 32-bit sequence numbers. At this time, it was okay because we have to do a full sequence number in, for example, 57 minutes. But nowadays, with 1 gigabit Ethernet or 10 megabit Ethernet, and if you compare to the packet life of a packet on the internet, you can see that it's really a problem, an issue. So there is a specific RFC for that called protection against wrapped sequence number, and that puts some an extension of sequence number using an option in TCP header. That was our example, okay? So how to know exactly what is the optimal size of the window? For that, you can use a very interesting measure called the bandwidth delay product. The bandwidth delay product is a way to calculate the 100% efficiency of your network. You multiply the bandwidth and the round trip delay time, okay? And for example, for our example, here 1 gigabit and 20 milliseconds, so the RTT is 40 milliseconds, we have a bandwidth delay of 40 million bits. In byte, that means 5 megabytes. If you put the TCP window size to 5 megabytes, then you have 100% efficiency. 5 megabytes compared to the 64 kilobytes by default. So you see that it's really very important to use that. So this measure is really good to calculate, to anticipate your issue with this kind of thing. So the RFC able to manage the increasement of the window size is this one, and you can go up to 1 gigabyte. So I think we have some time before the next RFC, I will say. Regarding the congestion, sometimes, I told you, if you have a congested network, it really affects the performance in a very, very bad way. And if it's not controlled, you can really completely have your network done. Here, it's what we call the congestion collapse. You can manage congestion with a lot of RFCs. And if you manage that, you will be here in a controlled situation. But what is important to notice is that the control is less than the ideal, because we have to calculate the useful packets. And if you put a lot of controls to control the congestion, of course you will lose some useful information for your protocols. So I won't detail all the RFC, of course, but all these RFC are used to manage congestion, manage error, and so on. So one of the most famous is the first three ones. For example, here's a selective acknowledgement. You can really say we have for this packet or this segment acknowledge. Oh, it's not easy to pronounce for a French guy. Sorry. And you have also the fast retransmit. If, for example, you notice that some TCP segments are bad, you don't wait for a special timeout, a specific timeout. You will say, oh, there is an issue. I will retransmit immediately. I won't wait for the delay. So if we look at Riverbed, clearly they manage this kind of thing. They manage high-speed TCP, so it's the usual TCP. And here is the MX-TCP, and here the high-speed TCP. And high-speed TCP is very interesting for high bandwidth, high latency product, like, for example, satellite link. It's really interesting because you can use in a better way the TCP connection. MX-TCP is completely specific to Riverbed, so it's not something in an RFC. However, it's based on the fast retransmit algorithm. So in order to manage all error in a network. Silverpeak also have a lot of TCP acceleration. Here it's just a copy and paste of the documentation. You can see the window scaling, the selective acknowledgement, the high-speed TCP also. Bluecoat is exactly the same. All the RFC I presented quickly are used and in the product, and the same applies for Branch Repeater. So it's really common for all the 4 products. They have some TCP enhancement based on the RFCs, well-known RFCs. Nothing special between 2 products here. Riverbed said that he have some kind of adaptive TCP optimization, but I didn't see anything concretely, to be honest. Regarding the packet loss optimization here, it's something very interesting because I talked already about the struggle between Citrix and Riverbed regarding the support of the Riverbed solution. Here the struggle is against Silverpeak against Riverbed. Silverpeak is very proud of his forward error correction and his packet order correction. Okay, he said I can optimize, I can compress, I can deduplicate, and if the packets arrive in different order, I can reorder them. Okay, and the same for FEC. It's very simple. It's exactly like a parity bit algorithm. That is, every n packets, a special packet of parity is sent. If there is one error, we can rebuild the packet. We don't have to send it again. Riverbed said we use selective acknowledge, in order to manage error, and we can control the order of the packet even if we compress, even if we deduplicate with a specific parameters named Q equal to packet order. And here, Riverbed said that forward error correction is ineffective for network congestion because of consecutive drop packets. Actually, here, the forward error correction is interesting if you have an error in one packet. You can correct it, you can rebuild the packet. However, if you have congestion, a lot of packets, several packets are destroyed by the routers. So FEC doesn't help, okay? And that's the point of the struggle between Riverbed and Silverpeak about that. And they said avoiding network congestion is more effective and doesn't have control bits, and the good put is better. And to be honest, I agree with Riverbed in this way. If you have a bad link, okay. If the error of the packets comes from a bad link, a low quality link, it can be useful to use FEC. But if it's only for a congested network, it doesn't help. So compression and deduplication. Riverbed is very famous for this point, that is indexation and deduplication. Here we have the data center, the branch office, and two Riverbed steelhead appliances. So when a request is done, the file is completely indexed, deduplicate, and then the flow here is sent in a compressed way. Okay? That means that here between the first time you send the files, you will send only a part of the files, and you will compress this part of the files. So you win already the first time. But of course, it will be more interesting the second time than the other times because here the data is stored. So the rebuild is done here on the appliances. So that's a very interesting mechanism. It's not exactly like caching. There is some cache, of course, here, but I don't know if you remember Expand. Expand was really only a caching appliance. You put the file, you compress it, and you put it on the other appliance. Okay? Here there is before an indexation of the file and the deduplication. And the deduplication is really very, very important. Silverpeak is completely different because Silverpeak is working on the layer 3, so the network layer, the IP layer in the OSI model. So it's completely independent of any application. It doesn't care if it is RDP, ICA, PC over IP, or anything, because it's on the IP level. It doesn't know what is in the packet. It does deduplication, exactly in the same way as Riverbed, but on the IP level. It is a good thing, a bad thing, difficult to say. What you can notice, if you are working at the IP level, that means that you can manage also UDP protocol. And with Riverbed, you can manage UDP protocol only since few months, since December, last December. Okay? And we will talk about that when we will talk about PC over IP, because it's a UDP-based protocol. So that's interesting with Silverpeak. Application independent, no plugin at all for any protocol. Bluecoat. Bluecoat, I would say it's the old-fashioned, old way. That is, it's byte caching and compression, no deduplication. Okay? So, and here also they have some optimization for, I think, about 10 different protocols, like HTTP, CIFS, and so on, but nothing for ICA, RDP, or PC over IP. Okay, just simple, I would say, byte caching and compression. Branch repeater, of course, specific things for ICA. First of all, cross-session compression, so that's logical. It's also the same for the other one. And you can specify service class policy for a certain IP range and port range. And you can, for this policy, enable and configure acceleration or end compression. The compression is called adaptive because branch repeater can recognize the flow, and it will apply a different algorithm according to this flow. If it's a printer flow, it won't be the same compression as, for example, ICA or RDP. Okay, so that can be really interesting. Otherwise, it's also the old way, that is caching. Quality of service. Quality of service, so only for a remote desktop protocol. For Silverpeak, we already say that there is nothing specific because it works at the IP level. It doesn't know what kind of protocol it is in the packet. It's the same for Bluecoat. And here, for Riverbed, they have a specific Citrix plugin. They have a lot of specific application optimization, like for CIFS, HTTP, auto, CAD, and so on. But they don't have anything specific for RDP or PC over IP. I let you guess for Citrix if they have anything as quality of service for ICA. Of course, yes. For Riverbed, be careful, by default, it's completely disabled. So you really have to know that you want to optimize the ICA protocol in your wide area network. So to optimize the ICA traffic, first you have to choose the queue. And the queue, as I told you, it's important here to have a packet order, because otherwise packets are not reordered on the second appliance, and of course it can cause a lot of problem for the users. So you have to choose packet order. If there is a very high packet loss, like satellite, for example, you have to choose the MX-TCP. It's HS, high-speed TCP. Choosing the class then, so they have now 6 different classes. And for ICA, because it's a real-time protocol, you have to choose either between real-time or the second step that is interactive. If you have voice over IP, that is most important than, more important than ICA, you have to choose a real-time interactive for ICA and real-time for voice over IP. Then select deduplication and compression in memory, because you can do it also on disk. But because ICA is a lot of small patterns, it's more effective to do it in memory, and the results are much better. And then apply shaping. So the difficulty here is to estimate your reserve bandwidth, because you don't know exactly at the beginning. So you have to do some tuning to know exactly what is the best here value to apply. And then you can also prioritize inside the ICA traffic. That is a specific thing with Riverbed. How do they do that? They are using what we call the ICA priority packet tagging, defined by Citrix. And so that comes from this knowledge, so KB, with 4 different priority corresponding to some virtual channel inside the ICA protocol. For example, I'm not sure you can read, I'm sorry, but the highest priority is for keystrokes, bitmap update, and movement. And for example, the background priority, the lowest one, is print traffic or auto client update. So, and with that, you can say, okay, I want to prioritize some virtual channel or not, okay, between each other. And they also have the ability to detect the client drive mapping with a simple parameter here. So, comparing to Silverpeak and Bluecoat, clearly here, Riverbed can really go into the ICA protocol in order to optimize it. Regarding PC over IP, it's interesting because PC over IP is based on UDP and TCP, but TCP is only used for session establishment and control. All the data are really only in the UDP session. And if you look at the VMware View 5 PC over IP guide, you can read that it's not necessary to use one accelerator. And I asked to the VMware guys here, and they told me exactly the same thing. Okay. However, we already seen that a lot of optimization cannot be done at the farm level. So for me, we can optimize not if we want, but it should be great to optimize. And since the last version of Riverbed OS, UDP is optimized. However, because it's an encrypted flow, it cannot do a lot of things in terms of optimization. What it does, it adds a buffer, it fills the buffer, and in this buffer, it analyzes the data to see if there are some deduplication. If it can do some deduplication, then duplicates, compress, and send. So nothing with PC over IP, especially it works for any protocol, but it's not like a plugin like ICA, for example. And interesting also, if you do a search of PC over IP on the Riverbed website, you find only one thing dating from August of last year, saying that VMware, Teradici, and Riverbed will work together in order to improve performances of PC over IP. You just find the press release. So I think it's not good enough. Branch Repeater. Branch Repeater, of course, Citrix knows his own protocol, so it can do a lot of things that is impossible for the other one, because it's a proprietary protocol. For example, it can prioritize ICA traffic based on desktop group name, for example, desktop, on publish application name, so they can really go deep inside the ICA protocol, and ICA priority tag, exactly like Riverbed. A new feature since Xen Desktop 5.5 and XenApp 6.5 is the ICA multistream. That is the ability to split the ICA protocol in different TCP flows with different ports, and then to optimize exactly what you want. Okay. Of course, ICA multistream is not supported yet by Riverbed. And I already talked about the adaptive compression. So, 2 user case before the conclusion. The first one is for a building and civil engineering works company for 600 users and 45 branch offices. And these branch offices, as you can see, they are either very, very small, 1, 2, 3 users only, with an ADSL line, to larger branch offices with 15 to 30 users with SDSL 1 or 2 megabit per second. So we categorize the users, and we find a lot of task worker, but also some AutoCAD users, about 60, and distributed in several offices. So it wasn't possible to use desktop virtualization for all of these users. And we had to combine users with desktop virtualization and users with typical fat clients. Current architecture was distributed with server on each office. It was really ugly and very difficult for to administrate. And the aim of the project was to centralize all the data and the application. So the solution, currently in a POC, is Citrix XenApp with Sync client for task workers and FAT clients for AutoCAD users. And after a first study, we decided to choose Riverbed because of the specific optimization for AutoCAD, because it was really, really interesting. Branch Repeater wasn't able to do anything interesting regarding this application. And for ICA, to be honest, it was really good. It was about the same as Branch Repeater. And because it was a full desktop, we didn't have to deal with publish application prioritization or something like that. So for large branch offices, we will put a Steelhead appliance after the POC if it works. And for small offices, we can use Steelhead mobile on repurposed PCs. Okay, because for 1 or 3 users, it's not good enough. It's not interesting to buy a complete appliance to put on the network. Use case number 2 is in healthcare for 400 users and 23 branch offices with 1 to 2 megabit per second SDSL line. And here we have some power users, but it's only in the LAN, in the headquarters. So we don't have to deal with these users in the WAN environment. And mainly, they are task workers with just office, mail, and 2 line of business application. What is interesting here is that any branch office of these 23 can have up to 15 additional users for a short period of time because of training. Because here in healthcare is association to help the hospital in France to do the training for the people working in hospital. So we propose a desktop virtualization with 95% XenApp and only 5% XenDesktop for the power users. And it's 100% ICA in the branch offices. And because of the 100% ICA for branch offices, we decided to put Branch Repeater to have also an end-to-end solution with Citrix only. And no problem of support or something like that. Okay, and it works really well. It works since several months, and it works really well. And a customer is really happy with Branch Repeater and XenApp. So, conclusion. Citrix Branch Repeater is the only one accelerator able to go deep inside the ICA protocol at the publish application level, for example. The only one able to manage the multi-stream technology, new technology. However, Riverbed can really prioritize also ICA in a very, very good way, but the priority, but it's not currently supported by Citrix, and I think it won't. They really struggle, and I was 2 weeks ago in San Francisco, and I asked to the product manager, and they want to support only Branch Repeater, and I will talk just later on that, Cisco WAS. Silverpeak and Bluecoat are interesting, provide some benefits, but not specific to desktop virtualization. It's good, it's TCP optimization, it's caching, and so on. It's interesting, but there is nothing specific. You cannot work at the ICA, RDP, or PC over IP level, for example, as Riverbed does. And to conclude, a few months ago, Citrix, with the partnership with Cisco, explained that Cisco WAS, so the product of Cisco, so one accelerator of Cisco, will support officially ICA. We'll be able to analyze, to go deep inside the ICA protocol. So we will look what happens, because it's only an announcement. There is nothing really actually. But I know a friend working in Germany, and they already have the beta version. So it's already written, okay? And he told me that it was really interesting for the moment. Do you have any question? Yeah, let's just wait for the micro. Thank you.
What sort of latencies were you looking at on your test cases there?
Sorry?
What sort of latency were you looking at on the test cases there? Because we've had a lot of problems with latency.
Yeah, so latency, it depends. For example, for this one, it was only offices in France, so with, I would say, good latency, about 40, 50 milliseconds. However, 3 of the 23 were based, in the French Antilles, so overseas, and then the latency was really bad. It was about 200, 250 milliseconds, and without Branch Repeater, it was completely impossible to work. And with Branch Repeater, it was really good. So up to 200 to 150, I can tell you it works really well. The jitter was not very high. I think it's also important for the test.
What sort of clients were you using on the other end? Were you using fat clients with the receiver, or were you using thin clients?
No, thin client, but with Windows 7 embedded. Yeah, it's very important also to have the best ICA client.
Yeah,
I agree.
What we found too.
Yeah, sure.
Do you have a sort of you have a sort of feel for the, you're talking about the individual accelerations, but what you're talking about site-wide or farm-wide accelerations. Do you have any feel for that? Any advice? Because Branch Repeater is the only one that can do that.
For Citrix, you mean? Any advice? What do you mean?
Your advice so far is really focused on like the individual connections, but the
Oh.
Branch Repeater was able to open up the channel
Sure.
and do
Cross session. It's cross session. Yes, exactly. Yes, it's cross session. It's automatic. You don't have any thing to do because it recognizes the ICA protocol. So automatically he works with this multi-session algorithm and encryption and deduplication.
I would like to know, most companies usually outsource their networks, especially on a global scale, adding MPLS or whatever, mostly MPLS. If you add another component like WAN optimization, Riverbed, what would you advise? Who and how should these devices should be managed?
It's a tough question. So you really have to deal with the outsourcer. If it doesn't want to have any, because it was released with two appliances, you need two appliances. It's not like Packeteer in the past with only one. So you have to manage effectively that in the outsourcer side. And it's difficult because I don't talk about architecture in this presentation because of lack of time, but the question is, where do you put the appliance? Directly after the router, and then it's really physical if it doesn't work. And but for an outsourcer, it's not possible to do that. So you have to redirect the flow with WCCP protocol, for example, in order to manage that. So it's really an issue. So it's really tricky to manage that and to manage high availability of the main appliance. But so I had several projects with this kind of products, and only once an outsourcer didn't want to use a one accelerator. Otherwise, it was okay. But only with one technology, for example. Non-company in France wants to work only with Riverbed, for example. If you say, I want a branch repeater, I say, no branch repeater, Riverbed only. That's an issue. Okay, thank you very much.